All right. Hi guys. This is Raymond again. We're back to complete our learning of Python. And if you're just coming in, my task for today is to get you guys through all the documentation for Python, as well as teach you how to code with it. The reason for us using the documentation is because a lot of the times, or many of the times, we hear about programming languages, but we never reference the documentation for it. And so, what we did in our previous video, we did chapter 2, which was getting to know the Python interpreter. We ran some codes, we went through some other stuff, and we are now here. We did the installation as well, which took up a lot of time. So now we'll continue to the next topic, which is an informal introduction to Python. I know, guys, it may be a bit tedious to go through the documentation, but over a period of time, you'll find that all languages that you may want to learn will require that you do it in this route. While YouTube may have a lot of excellent resources, nothing beats the documentation because it does give you some tips and tricks that you may not have thought of. Alright, so let's go. In the following examples, input and output are distinguished by the presence or absence of this triple more than sign. And the, I guess, the triple dots. We've seen this when we ran the code yesterday in the interpreter. To repeat the example, you must type everything after the prompt. When the prompt appears, lines that do not begin with the prompt are output from the interpreter. That is something that I'll have to show you rather than have it being read. Um, but we'll scroll down. It says you can toggle the display prompts and outputs by clicking the triple sign. Alright, so I know if we run this in the command line, this won't be the case because it is a still. But what we can do is perhaps open one of the Jupyter that we had before and see if it is true, if it holds up to what is being said there. Alright, so let's see. We'll continue though. That is something that we'll have to verify. Alright, so it says if you hide the prompts and outputs for an example, then you can easily copy and paste the input lines into your interpreter, which is what we'll do. I might not code this time around to save time, but I'll try to give you my insights on what's being done. That way you can have the documentation as well as a secondary source of information. So I'll summarize all of the statement and highlight this one asterisk. And what this does in Python is it allows you to comment out code, which means that the interpreter will not recognize this line of text as a portion of the program, but instead it will be used for documentation purposes. That's what all of this right here is saying. We move on. We will not be wasting unnecessary time. Alright, so here we have a comment and we have a variable which is palm and we have the number 1 that is assigned to it. We also see that what has been said is that the asterisk sign can be used just about any part of the code. And here we can see that the asterisk is used on top of the statement, and here we can see it's used in line with an existing piece of code. Then we can see that it's here, uh, and remember when we did use the while loop yesterday, because Python requires that you use the spaces to facilitate stuff being done appropriately. you can see that comments do not adhere to that, because as I mentioned before, the comments are not an existing part of the actual executable code. It's only there for documentation purposes. So now we have here another variable, which is text. So let's highlight both variables. We have a spam and we have text. Spam has a value of 1 and text has a string value. As you can see, now we have the asterisk sign that's inside the quotations. So that is how you have the quotation displayed. It has to be in between the quotations, whether it be single or double. And so what we'll do is we'll run this and see what result we get in the Jupyter Notebook. All right, let's create. All right, this right here is a markdown. What I did previously is I clicked outside and I typed the letter M. That is a shortcut to do a markdown. So I'll do this, I'll do that, I'll hit the asterisk twice, which is Shift and 3, and I'll say this is day 2. Yeah, day 2. Day 2 of learning. And we'll hit Shift, then Enter. So this is Jupyter Notebook, and it allows you to document as well as code in Python. So what I did previously is I hit the asterisk twice. This is different from the single asterisk. And the cell is formatted different because I have it formatted as a markdown instead of a normal cell. So I'll hit Control V to copy the code that I previously to paste in the code I previously copied. And here we can see how it looks when you have the single asterisk used in a normal cell. Remember, this cell is formatted for a markdown, whereas this cell is just for a normal block of code. So now we'll hit Control, we'll hit Shift and Enter, and the code has been run, and there weren't any issues. Um, so when we go back here now and reference what was being said about the triple dots, it's up above here. Uh, yeah. All right. We'll bypass that that particular statement, but I believe it's more semantics than it does have an impact on the code, so we proceed. Alright, so now we are at 3.1 and we're going to be using Python as a calculator. Yesterday we had previous experience doing that, and so yeah, I still have the Jupyter Notebook open. Um, but just so you can have a bit of interaction with this existing code, we'll just type the text. And here in the Jupyter Notebook, if you hit Tab, you can see that the variable name is completed. So we'll hit Shift and Enter. And here we can see the text that is within this string. It's outputted right here. So for the rest of the tutorials, I'll be using the Jupyter Notebook, unless I see it's fit that we use the command line interface. But I want to use it this way so you can clearly see the different types of data that you're using. We have the different types of structures that you're using. We have a string, we have a comment up top, we have a variable being declared, which is spam, and we have a comment behind it. And as I mentioned before, the comment do not adhere to any of the Python rules. It's only for documentation purposes. But I recommend that if you will be using comments, you use them to make the person's life a bit easier. So we've seen what's stored in the text variable, And now we'll see what's stored in the SPAM. SP, let's use tab again for the sake of laziness. And we can see that we can see that one is in the variable, which is SPAM. Alright, so moving on, let's see if we can get a bit more done in a shorter period of time. So the interpreter acts as a simple calculator, and the interpreter is pretty much the command line interface, which would be some back end coolness. I'll leave it at that. Alright, so it says the interpreter acts as a simple calculator. You may type an expression and it will, and it, you may type an expression at it, and it will write the value. Like, alright, fair enough. The expression syntax is straightforward. The operators plus, minus, asterisk, and I believe that's the backslash or front slash. Yeah, you know what which it is. So it says they work just like most other languages, like Pascal, C, and the parentheses, which would be the brackets, the over brackets, can be used for grouping. If you guys are familiar with PEMDAS, which would be the order of operations that each one of these may fall under, PEMDAS is a mnemonic to specify which one has a higher precedence. Usually it's parentheses, exponents, which in this case would be, it's not here, but it's usually a double asterisk. Alright, so let's move on. Let's copy and paste it all, guys, and see what our response is from the Jupyter Notebook. Normally, when you're learning to code, it's required that you do all the typing for the sake of learning. Um, in order to make this fair, we'll have to do it one by one so we can see the actual output that is desired. So here, instead of us using, let's try it. We'll do control and we'll do shift and see what happens. Yes, we can keep those triple more than signs there. I believe it's called it's not an insertion operator, but you know what it is. Alright, so we'll move on. We'll press the letter B to create another cell below it. We'll paste in everything that we had prior, and we'll delete the 4 because we see that works out quite well. So it's seen that if you simply type in the values that you request, you will get an output, and this is quite similar to the command line interface. Whereas if I did this, which is to copy and paste everything that I had before, ooh, looky there, there's an error. Multiple errors. Multiple errors. Alright, so what I'll do is I'll have to do it the manual way. So let's say we had 2 plus 2. By simply pressing enter after that, we get the output that is expected. So while we can do all of that neat stuff in the Jupyter Notebook, we will not get away with it in the terminal. So as you can see here, we run the cell and the last one that is below is executed. And there's a comment here that says division always returns a floating point number. And a floating point number is simply stating that it's a unique data type that stores decimal values, uh, or floating point values rather. Alright, so as you can see, we're dividing two integers, but when we're dividing, we will always have a floating point as the number. Here we can see up top, let's divide these two, control X. Here we have the expected value being 20, um, and this is because here the order of parentheses does the 5 times 6, which will be 30, which is subtracted from the 50. If we would want another result to be done, we'd have to specify what order we want it to be in. And that is exactly what's being done in this block of code right here. The result is also shown. So we can see that it's the 30 minus the, well, it's 30 from the 50, which would be 20 divided by 4. So we have 20 divided by 4, which would be 5. And it's done in that order because we specify that we want this being done first, then we want to divide. Uh, and let's see what would have happened if we would have removed the bracket. This is the significance of the bracket. Remember PEMDAS, guys? The parentheses is higher in the precedence order. Then you have exponents, and you have multiplication, which is this. Then we have division. So if I'm correct, we are going to subtract. We are going to multiply first, which is 30. Uh, then we divide that by 4. 30 divided by 4, that would be half of 30 is 15. 15 divided by 2 would be 14.5. Yeah. So that's what we're going to get. So we'd have the 50, and we'd subtract 14 from point 5 from that. That is the answer that I'm expecting. There we go. So yeah, that is not the original 4 5 that we had. And let's see how it goes. Let's do Control Z. You can see how the brackets does, the parentheses does make all the difference in the order. And yeah, that's why you use your parentheses, to specify in what order you want to group your polynomials or your equations, your expressions. And so we move on. It says the integer 2, 4, 20 have type int, and we can see it's 2, 4, and 20. I see a 2, I see a 4, and I see a 20. Have the type of int, which would be integers. The ones with fractional part, which would be the 5.0, 1.6, that would be here, and the 1.6, have type float. So integers type int specifies integer values without any decimals. And float that shows decimals. Yeah, got sidetracked. Family, gotta love them. The integer numbers. Yeah, we went through this. All right, so with the division always returns a float. That is one of the comments that we saw up top, which is here. There's another operator that has the division sign used. It's a double division, and it is considered its own operator, and it calculates the remainder. You can use modulus to calculate the remainder. Alright, let's see how this goes. So here we have 13 divided by, my apologies, we have 17 divided by 3, and the result is going to be, let's run it. Yep, 5.2 66666, you see what it is. And this right here is a float. The float is expected. And so in the second line, we can see we're using the second operator, which would give us the floor of the division, which would be the remainder of the value. So 3 divided by, you have 17 divided by 3, that would be 3. Oh, my apologies, 5, remainder 2. Ooh. Oh, okay. Alright, so it gives you the whole number, the floor. Alright, so it disregards the remainder. And if we do the same thing here, I believe it's already here. If we do the modulus of that same statement, that would give us the remainder for 2. Yep. So this pretty much rounds, I'd say, it doesn't rounds, but it specifies the number, the amount of number that can be divided, and it disregards the fractional part. And so the modular sign allows you to get the fractional part of it. So these two operators work hand in hand. Um, this way you ensure that you don't leave any portion of a value to not be calculated. Alright, so we're going to move on to the other line, and it says the floor quotient multiplied by the divisor plus the remainder. So that would be this. And we can already see the expected value is to be 17. So we'll click here. Let's close this since we won't be using that. These are contents that we went over yesterday. We'll close that. Oh, yep. And that's it. When the order of the operation already suits your need, you won't need to use any parentheses. But if it's not, then just be cautious of that. So we have the 3 times the 5, which would be 15 plus 2. That's the 17 right there. And here's the comment that indicates what's being done there. So we're going to go back to the documentation and see how exponents are, well, the powers are used. With Python, it is possible to use the double asterisk operator to calculate powers. So 5 raised to the power of 2, which would be 5 times 5, is 25. Let's try it. Let's get it in there. Let's do a M. Alright. We'll do double. Let's do powers. Exponents. And for those who are within the UK, let's do indices. Yeah. There we go. I believe that's how it's spelled. Alright, so we'll hit shift and enter. This is the only one that doesn't have an S. And these are not capitalized. Let's do that. Shift enter. Alright, so we'll now control V, enter that, and that's the answer we're expecting. 2 raised to the power, 5 raised to the power of 2 is 5 times 5. And just so just to clarify what we already know, let's do A equals 5. Then below, we'll do A times A. Yeah, let's do, I want it displayed. So let's do print. There we go. A times A is also the same as A squared. Well, 5 raised to the power of 2. It's done the same way. And let me show you an even cooler way to do it. You may also do it like this. A, we're skipping steps here, but you'll eventually get it. You can do A as equal A. Let's see if this is something that you do in C++, but I just want to attempt it to see if it's possible to be done in Python as well. So what this statement is saying, we're going to take the value of A and we'll multiply it by A and we'll keep that. Let's see if it works. No, it does not. It does not. It does not. Well, it does not work. It does not work. So for Python, it's ooh, it does work. It does work, but you can't do it in a you can't do this operator in the print function. Ah, no, that is sweet. That is sweet. Yeah, so you can use this layout as well, which is the asterisk multiplied equal A. It does work, but you can't have it displayed in the print function as you would this main statement. All right. And I believe it's because this is assignment operator as well. It's multiplying as well as assigning a new value to A. So if we were to run this line of code again, it would mean that we're multiplying 25 by 25. And let's see what we'd get there. We'd run that, then we'd run this one more time, which is 625. Yeah, it works, it works. All right, let's go back to the documentation and we'll see what else we can do. So we've used the exponents, and here we have 5 squared. Let's make it official and use another exponent other than 2. So we'll go 2 to the 7th, which is supposed to give us a response of 2. That's supposed to give us a response of 128. Yeah. Oh, and for this operation, guys, this will only work for squares. It won't work to multiply any other value higher than 2. Um, yeah, so that's that. So here we have this being done. We'll hit shift and enter, and the answer is 128. If you doubt it, let's pull up a calculator. And we'll do 2 raised to the 7th power. It is the 128, guys. Alright, so it's correct. And so now we are here. We're saying the equal sign is used to assign a new value to a variable. Afterwards, no result is displayed before the next. Ooh, alarm. Alright, so the assignment, the equal sign is used to assign a value to a variable. Afterwards, no result is displayed before the interactive prompt. Mm-hmm. All right. All this is saying is that when you're assigning a value, there isn't anything that is done. Uh, so let me show you that in Python. This is exactly what happened here. We were giving a new value to A. But I'll show you again. Let's say we want it to be B. B equals 365. That's an entire year. When we're just giving the variable a value, or when we're assigning or initializing the variable with a value, and we hit shift and enter to run that cell, nothing is done. However, if we were to type B again, we can see that the value is stored in B. So here we're initializing. When we use the value again, we're calling the value. This is quite similar to how you'd create a function. You'd give the function a directive, then you'd call it by referencing the name. Moving on, here we have, alright, so we were just mentioning the assignment operator, which is the equal sign. If a variable is not defined, which means you assign the value to it, trying to use it will give you an error. Let's put it to the test. Our next variable that we create will be C. And we'll say C, then we'll run it. C is not defined. Alright, we'll give C the value of cat. And we'll run it. C is defined, so there isn't an error. So that was all that previous statement was saying. If you don't have a value assigned to C, you will get an error. And we did see that error come up. And the error will say that the value that you, or the variable you created, is not defined. There is full support for floating point. Operators with mixed type operands convert the integer operand into a floating point. I believe that's what we did when the division was used. So Python dynamically assigns floats when necessary, and it's saying that whenever you have a float and an integer being used, your response will always be a float. Yep. Let's put it to the test. Yeah. Let's change that. We'll do a 4.2 or a 4.9, and we'll do 3. The response is a float. So what happens if we take away the point sign? Now we have an integer. So it seems the only credentials, or the only way you'll be getting yourself an integer as a response, is if all the values are an integer, and if all the values are integers and the division sign is not included. So even though we have integers being used, if we were to change this from multiplication to division, we'd end up with a float as well, even though these are integers. And that is one of the rules we went by, and it says, so as long as you're using the division sign, you will end up with a float as your output. Moving on, we'll scroll a bit lower, and it says the interactive mode, which we will not partake in because we're using Jupyter. The last printed expression is assigned to the variable underscore. We've seen this, but let's say if it's possible in the Jupyter Notebook. So our last variable that we run We'll come back to this. Our last variable that we ran was, ooh, our last value that we ran was this, 0.3. It wasn't a variable, but the last value that we ran was 0.33, this value. So let's do the asterisk plus 1 just so we can identify whether or not it was. And yes, it is. It still applies. The asterisk does have the same precedence as it would if we were using the command line interface. And so, yeah, that still holds. So we'll move on. We won't waste any more time with that because I did some practice previously with it. And you can see that you can have that being a part of equations, and it's very efficient for you to reference previous value using the asterisk uh, to prevent having to call either an entire equation as we did prior to, or having to reference a variable name. It just makes it faster to reference a value or an equation after it has been run. And so now we go down a bit lower and it says this variable should be treated as read only by the user. Don't explicitly assign a value to it. You would create an independent local variable with the same name asking the built-in variable with its magic with its magic behavior. I'm not sure what they're saying, but I like to put things to the test, so we'll find out what that is. So we'll go here and we'll create a variable that's underscore, and we'll say it's equal to 2. Yeah, it works. And so now we'll do 25 times 3. That's 75. And so now I'll say the next value that I'm expected to see is this 75, which would be the previous value that I used, plus 5. Let's see if it takes the 75 or if it takes the 2. Let's see what it does. It goes and it takes on the 2. So if you assign a variable to it, it will lose its magical powers. So let's delete this variable. This is bad juju for our magical variable. And as a matter of fact, let's reset the kernel. Let's restart. Let's restart the kernel because it may still be stored, and we don't want that to interfere with what we're doing. So I'll come here. I'll run the 75. Yep. Then I'll come here, and the answer should be 80. Yes. Alright, so stay away from assigning a value to the underscore, because then you'll lose the functionality of being able to call any previous equation that was calculated or a previous variable that was called. Alright, so that's all that's saying. Alright, so the variable should be treated, we did that. In addition to int and float, Python supports other types of numbers such as decimal and fraction. And I do believe that these would be able to handle decimal values. It says Python also has built-in support for complex numbers that use J or capital J suffix to indicate an imaginary part. Alright, so yeah, imaginary numbers are used in Python, and I believe that's one of the reasons why it's very, very efficient in data analysis and data science in a whole. Alright, so let's go with strings. Besides numbers, Python can manipulate strings, which can be expressed in several ways. They may be enclosed in single quotations or double quotes in the same, and they'll give you the same result. the front slash can be used to escape quotes. Alright, so what this is saying is that by default, the single quote and the double quote will allow you to output, or not output, but store strings. And it says if you'd want to have one of the quotes displayed, you'd have to use the escape character, which is this front slash. So let's see how this gets done. All of these are individual lines of code, so we'll have to do it. Yeah, we'll have to use them separately. Alright, so we'll come here. This is a normal string. We'll hit shift and enter, and we can see it outputs the specified string. Now the second line, it has the escape character, and so what we're going to see is that it will output doesn't and have the single quotation being allowed to show as well. Alright, there it is, doesn't, and we can see it doesn't affect the single quotation mark. Alright, moving on. So if you want to keep any one of those special characters, you'll have to use the escape string operator. And that's about it. It applies to the double quotes as well. And this is what it is right here. We'll use this one just to get across what we're trying to show here. Yes, so because the escape string has the escape character is in front of this quotation, it is outputted, and it's here as well. So this character as well as this character is not seen as an error, but it's negated by the escape string. Alright, moving on. In the interactive interpreter, which would be the command line interface, the output string is enclosed in quotes, and special characters are escape string with backslashes. Alright, while this might sometimes look different from input, the two strings are equivalent. The string is enclosed with double quotes if the string contains a single quote, and no double quotes otherwise if it's in single quotes. So that would be one of the ways you can decide whether or not you'll want to use the single quotes or double quotes. Because here it's saying if you use the double quotes, within it you can use single quotes as well. Whereas if you're using the single quotes, you're implying that you won't be using any quotations unless you intend to use an escape string. It says the print function produces a more readable output by omitting the enclosing quotes and by printing escape and special characters. Alright, so let's see how this gets done. Here we have S being assigned the value first line. There's a front slash N, which means new line. So what we're saying is first line, new line, then the second line is supposed to be outputted. And here we have the print function that is used on this variable, which is S. So instead of going over all the examples, I'll go over the one I find most unique, and if I see that there's anything else to highlight, then I will. Because both of these are quite the same, they don't differ in any way. Alright, so let's see. We have S Let's see what happens if we simply type S and run shift and enter. We can see that it's treated as if though it's a normal string. The front slash n is not treated as if though it's a new line. But if we use the print function, which was what was said in the documentation, if you use the print function, you'll have this being your output instead. So while you just simply output it or call the S, you'd have this entire line, and this would still be seen as a string. Whereas if you use the print function, it understands what you're trying to execute, and it does so quite eloquently. Yeah, that's neat. All right. If you don't want characters prefaced by the front slash to be interpreted as special characters, you may use raw strings by adding the R in front, well, before the quote. And this is it right here. This is what you'd be doing. hmm So it would be here, you'd be doing that. Because here we'd see the location for a particular folder, and you'd want to keep the front slash as a part of the string. So in that case, you'd use the print function once more, and you'd have R outside of it to ensure that the front slash n isn't treated as if though it's a new line. So let's run it. We'll copy this, and it is required that you type your code, guys. It does something in your memory. It allows you to trigger some muscle memory when it's most needed. So let's print this out. We have some name, and if we remove the R, we have it as some. The name, the n isn't even displayed because it's seen as a new line, and that's what we are trying to avoid. Yeah. Oh. Yeah, a bit of. Alright, that should be it. So it would be the R being in front of the single quote, and that's it. Alright, moving on. Here we have the triple quotes, triple double quotes, or the triple single quotes. And it's possible alright. Alright, so it says string literals can span multiple lines, which means you can have an entire block of text being identified as a string literal. And one way of using triple quotes or double quotes. Yeah, you can use the triple double quotes or the triple single quotes. End of lines are automatically included in the string, but it is possible to prevent this by adding the front slash at the end of the new line, at the end of the line. For example, interesting. Control V, then Control, well, Shift Enter. Here we see exactly what was expected without any additional spaces. But let's see what happens when we remove this. Let's see what's done. You have a space that is on top. Ah, I understand why. Alright, so the space is removed if we have the front slash. That way, I guess that space is within the escape string. so it's no longer a part of it. All right. It says produce the following output. Note that the initial new line is not included. That would be the exact code set of code that we just ran. Well, so we won't be doing that. We'll move on to this. That says strings can be concatenated, which means to glue them together with the plus operator and repeated with the multiplication operator. Ooh, looky here. Oh man, getting a bit sleepy. Let's see if we can get through this and call it a day or a night. There's a lot being done here. And we're just about maybe a little less than halfway through it. So let's sprint through this and call it a night, guys. Alright, so we'll copy this, paste that there, hit run, and all this is saying is that we're multiplying the on 3 times. Let's change this to something more inspirational. let's put the word million there. Let's put dollars there. Can we put that? Yeah, let's see if it works. If it works, yeah, it does. So we have million, million, million 3 times, and we have the cash emoji, inspirational. So we have 3 million there. Let's be ambitious. Let's do 10 million. Yeah. Let's do 100 million. I don't know why, but let's do 100 million. Let's do 1,000 million. Oh my. Inspirational. Yeah, I can see it. Now let's do this. Let's do this plus the, let's multiply the money sign times, let's say 5. Do we get the 5? Oh yes, we do. Let's reduce that and add some more. Let's add a 10 to that. Oh, so inspirational. Let's do 1,000. Yeah, I'm enjoying this. The money. Ah, the money. All right. All right. So you get a sense of what this is, guys. So you can use it to multiply a string as well as adding the strings to each other, because this is a string. So you can multiply the quantity that is in the string as well as add the strings together. So now let's do this. We'll use dot plus don't ask me why. Yeah, money plus unicorn, guys. It's being done. It's going down. Yeah, here we go. So we have millions of dollars and an abundance of unicorns with this one line of code. And yeah, let your imagination be your guide with this one. And we'll move on. We'll move on from here. Remember the asterisk? It's used to reference the previous variable that was used, and the plus sign allows you to concatenate strings together. And what I did was simply use the emoji of a unicorn and I multiplied it by 100. So we have 100 unicorns, and with the money sign here, we have 100 bands. Don't know how much that is. Then we have 10 millions up here. So we have 10 million, we have 100 bands, and 100 unicorns. Yep, moving on. Yeah, so that was fun. Alright, so two or more string literals next to each other are automatically concatenated. Yeah, we did that. We did it with more fun though. We did unicorns and we did money. Uh, the feature is particularly useful when you want to break long strings. Hmm, I see. Alright, let's see what this is. Put several strings within parentheses to have them joined together. Fair enough. So this is saying, like, let's say you had something that you were saying before prior in your code, maybe something having to do with a document or a name. Let's say it's first name, and then at a later point you requested the last name. You'd want them being in the same column, so you'd say, all right, I want to reference the first name that I got, and I want to reference the last name, and we'll use the concatenation, which would be the plus sign, to have both names stored together in one uniform string. And let's move on. Let's make it more applicable because you won't be using millions or unicorns. But let's say the first name is John. All right, and the last name is his last name will be Shepherd. Yeah, that. Yeah. What we're going to do now is we will say the full name will now be stored as first name plus the last name. And what we'll do is we'll print the full name. Which would be John Shepherd. And of course we want a bit of space there. So we'll do that again. Now we have John Shepherd. We added the space such that the name does not be too be that close together without any indication of a break. Alright, so that's one of the convenient way you can have that used. This was just me having some fun with the operators. And we'll move on. Multiplying strings, adding strings, that is the purpose of it. Yeah. Okay, I think I misunderstood what this was saying. This is highlighting the purpose of the parentheses when you're using oh my. why the parentheses was there. Alright, so the purpose of the parentheses, and apparently it simply allows you to do what you'd conventionally be able to do with the triple quotations or the triple single quotations or the triple double quotations. And even though we didn't use it before, let me show you what it's like. So here we have, ooh, nope, that's not what I'm trying to do. Let's have the exact same. If you can see here, these are two different lines of code. You can do it here like this, put several strings within parentheses, but what would be the difference between this is that when it's here between the double parentheses, double triple parentheses, it will keep this same layout. So let's see what it is. Here we can see that the line is not seen, but I know how we can change this. We can do print and have it within the print function, and the print function should have it separated accordingly. But we can see that when we use a triple quotation, it isn't seen as one string anymore. As up top, it's seen as two completely different strings. And so that would be the advantage of using the parentheses and having multiple lines in there. Kinda neat. Alright, moving on. This only works with two literals though, not variables or expressions. Alright, fair enough. So you'll only be able to do it with two, not three. But let's put it to the test once more. Let's see what will be the results if we try and do this. Invalid syntax. Invalid syntax. Yeah, it works. All of them it's in one line. So as long as the syntax is adhered to, it will work. Alright. But it says it only works with type string. Alright. This only, alright, yeah. Alright, let's move on. We have prefix being pi, prefix being ton. You can't concatenate a variable and a string literal. So I know this is a variable because it has the assignment operator. So that would means then that this is the string literal. Okay, alright, so it's saying you can't concatenate a string literal, which would be this, and the variable without the plus sign, which we did cover that before. So that's just making it known that you can't do it that way. Strings can be indexed, subscript, with the first character having an index of 0. There is no separate character type. A character is simply a string of 1. Alright, so it's saying all of these words, they're all characters and they can be indexed. So, being that this is the word Python, it has 1, 2, 3, 4, 5, 6 characters. And with variables, or rather with words, the index starts at 0. And it goes up from there. So if it's 6 characters, it will be 6 minus 1, which would be 5, from 0 to 5 that can be accessed. Alright, let's find out. Alright, so the word is Python. Now we'll do word and we'll reference using the square brackets the fourth character using the number 3. Let's count it off. 1, 2, 3, 4. So this should display an H. Yay, H. Alright, I'll summarize what we're going to do. You can reference a portion of the word by using a colon, Control C. And what this colon does is pretty much a generic way of saying where you want to start and where you want to finish. If you leave the first half of the colon empty, colon, and you say you want to start from, let's say, 3, which would be the fourth character. Let's say you want the fourth character onward. No, my apologies. It will start from the first character and it will stop at the fourth. So we are going to capture 1, 2, 3, 4. Let's see. Oh, we won't have the fourth included. We'll only have the third. So here we're specifying the specific amount of characters that we'll be using. Whereas if we had started at 3 and leave that open, we would have had perhaps the T up onto the N, or perhaps it will be the H up onto the N. Let's see. There we go. So it would be from the third. In this case, it's actually the fourth character going on up until the end. And if you want to reference the word starting from the back, you would have used a negative variable, which a negative integer, which would have say you want to start from 1, 2, 3, which would have be the H. So more than likely you'll have the P, Y, and T being displayed. No, it's the opposite. It's the H, O, and N. Ah, okay. So the starting location is at the third to the back. Then the ON is where it will be completed. So let's say we had this here, the X. We want it to be completed at the H. So that would mean then that we'd have the PYT being executed, or the H may not. Let's see. Yes, that's it. PYT. Alright, so let's see if we can skip a portion of this right here. Yeah, so the negative 1 would reference the last character, the second to the last, and of course the -6 would have been the first character. So that means we're just counting from behind. And that is something that you will get used to quite, uh, I guess, without any problem. So as long as you practice it. So we'll go on now. We're just halfway. I think I am going to have to end this off here. It's been over an hour, and though we've covered a good amount, I don't want to overdo the time. Let's see, where were we? We're almost done. Alright, let's see if we can push through. Yeah, so we did this already. Starting from the back or from the front, reference that as well. And let's see if we can start from here. One way to remember how slices work is to think of the indices as pointing between the characters. Oh, okay. Neat. Alright, there we go. The first row, numbers, gives the position of the indices 0 to 6. In the string, the second row give the corresponding negative indices from I to j. Alright, so it's just saying the reversed. Alright, attempt to use an index that is too large. Alright, so if you use an index that's beyond, you'll get an error message. I won't be showing you that. Alright, so however, out of range indexes are handled gracefully when using the slicing. So for this, what it will do is it'll just it will just output the last value. If they aren't for the two values, it will just output all the values they have. And if you start at an index that does not exist, it will just not give you a response. It will give you an empty string because the index does not exist. Python cannot be changed, they are immutable. Python strings cannot be changed, they are immutable. Therefore, assigning an index position to the string results in an error. Uh-huh. Yeah. So we can't change any of the values in Python. But let's try it. Let's see what happens when you attempt to do this. Let's do that. He 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 he. So this does not support any assignment. Nice. So you can't change any of it. It is correct. If you need a different string, you should create a new one. So in this case, we're adding j to the word. Then you can use the function len to see how much characters are within a string. We'll use that here on word. We already know there are only 6 characters in that, but we use the function just so we can get through with that. Alright, so a list is quite similar to an array. Oh, a list is an array. But what it does is it stores not one value, but multiple values and respect them accordingly. These can be accessed individually as well using the square indexing. and I believe they can be modified as well. So let's do this. Let's do squares. Let's copy this, and we'll run through the we'll run through some of the functions that that can be used with lists. And we are almost out of here. All right, let's see if we can sprint to the end with this. So here we go. Square. We have we have squares. The index is 0, 1, 2, 3, 4. So here we have squares. Let's access the fourth value, which would be 5. The fifth value would be ooh, would be 4. It should be the 25th. And we'll change that value to, let's say, 5. So now we'll do square. We'll print out the entire array again, and we can see that that value was changed to 5. There's a function that I saw, and it is the append. It is the append function, and what that does, it allows you to add a value or an equation that will ultimately give you a value. So, and that value is placed at the end of the array. So here we can see 7 raised to the third power is added on to the array, which is cubes. And this array is cubes because we can see it has the first cubes, the second cube, which is the 8, the third cube, fourth, fifth, sixth, seventh. And so the seventh cube would have been this right here. And yeah, that's what's being done. Alright, so let's move on. Let's use the append function on our existing squares. And what we'll do, instead of assigning it using the equal sign, we'll use the append. We'll append the value 50. And we'll call squares again. And what that should do is it should give us 50 behind, yep, the last value that was entered. And that's all the function does, append 50. And let's say we wanted 50 times 10, which would have been 500. We will now have both that 50 and that 100. Because we did not overwrite this value, it will not be overwritten, it will just be added on. Yeah, there we go. Yep. Alright, I think I want to go over this with more patience, or with more etiquette, because this will be used in a lot of stuff. So the next time I go through this, I'll stop right here, just so we can treat the arrays with a bit more respect, and give it the due diligence that it requires. Because here is where you'll be able to modify and in some cases add arrays to get the results that you need. So I'll leave it here, and the next time we come along, we'll catch up right here. Until next time, guys, this is Rim.